Welcome to our fourth unit of our course on exponential functions. Today we're going to look at lesson one, the law of exponents. This should be pretty much a review from previous grades, but it's a great review if you still don't understand some small things or the more tricky examples of evaluating or simplifying. Okay, so just remember, very basic. This is what we are going to consider a power, but within a power you have the superscript at the top there, which is our exponent, and you have the bigger number, which is our base, and altogether they make a power. Okay, so just remember that, and what it means is that it's 2 times 2 times 2 times 2 because you are going to times it, the base by itself 4 times because that's what your exponent is. Okay, from there you could evaluate, or sometimes we just ask you to keep it in the power form at the end. Okay, so remember the product law. So this is the first one. So we'll go through some examples. Sorry, I need a little bit better for there. That is terrible. So for our product law, remember that is when you are multiplying two powers together that have the same base, and the key there is that they have to have the same base. You are not allowed to do anything with powers that don't have the same base. Okay, so if we were to use our product law, you see that two powers are multiplied together with the base of a. We're going to then add our exponents. Okay, so we're going to look at this example. So 2 powers of base 2, keep the base, and then add the exponent. So 3 plus 4, so you're going to get 2 to the exponent 7. Okay, same thing here, base of 3, both the powers are multiplied together, keep the base of 3, and add our exponents, 8 plus 2, to give us 10. Okay, so here you don't need to actually evaluate that on your calculator. Those would be really big numbers, so just leave them like that. The only time that you're going to ask or you're going to evaluate is if you're asked to evaluate. Here I haven't asked you, so I just wanted to show you examples of using that product law. Okay, so only time you're going to do that is when you're asked to evaluate. Okay, remember our quotient law is when you're dividing two powers that have the same base. So you have the base of a. What do you do with the exponents? You're going to subtract them. Okay, so here 2 bases of 5, keep the base, subtract the exponents, 10 minus 6, and you should get 5 to the 4. Again, remember it's your numerator subtract your denominator, not the reverse. Okay, 4, and then 7 minus 2, which is your exponents, so you should get 4 to the 5. Okay, again, you don't need to evaluate them. Our last rule, or sort of last rule, is the power of a power law. So when a power is raised to another exponent, so you see a power and then you have another exponent, you will always see brackets here. Okay, so just be mindful, and that's how you know that it's a power raised to another exponent. Okay, what you do, you're going to multiply their exponents together. So you keep your base of 3, okay, and then you're going to go 2 times 3, so you should get 3 to the 6. Again, just leave it like that, don't evaluate. Okay, keep your base of 4, and then you're going to multiply those exponents, 3 times 5, which is 4 to the 15. Okay, again, just keep it like that. You'd get a huge number for that on your calculator. Okay, so another law that we're going to look at is called the power of a product law, and it's when the base of a power is the product of 2 or more constants or variables. So if your power or your base of your power is more than one thing, so here you'll see the base is a times b, then that means that this exponent has to go into both the a and it has to go into the b. Okay, and you're going to still multiply in between those two powers. So you just have to be careful with that and make sure that you're putting it into everything that's in the brackets. Okay, so here this 3, exponent 3, has to go into the base of 2 and it has to go into the base of 3. Okay, so you would write it as 2 to the power of 3 times 3 to the power of 3. Okay, and that's it. I won't ask you to evaluate, just keep it like that. Okay, this one here, the 3 has to go into the base 3, it has to go into the base x, and it has to go into the base y. So you're going to get 3 to the exponent 4, x to the exponent 4, y to the exponent 4. Okay, you could evaluate the 3 to the 4, but that's okay. Just leave it. Just leave it like that. That just says understanding that that exponent has to go into everything that is in that base. Okay. The power of a quotient law is the same thing. If you have the base of a power as a quotient of 2 or more constants, so you have a and b, that exponent needs to go into the numerator and it needs to go into the denominator. Okay, so our example here, so 2 over 3 to the exponent 3, you are going to have to do 2 to the exponent 3, because this has to go in here, and it needs to go in the denominator. Everyone always forgets the denominator, so you just need to make sure you remember that. Okay, same with this example. You have an x on the top. It needs to go into the numerator. It also has to go into the denominator, but it has to go into both things in the denominator, and that's from our last rule, right? So you have to go x to the 4 on the top, but then you also have to do 2 to the 4 and y to the 4. Okay, again, I'm not asking you to evaluate or anything. I'm just showing you that, so leave them in that form. Okay, so just make sure that you're following this and making sure you're putting that exponent into every part of the base that is possible. Okay. So let's do a bunch of examples now together. They're going to be a little bit more tricky. They're not just simple ones of me asking you to use the product law, okay, or the quotient law. I'm just going to get you to combine a bunch of these, okay? So you'll notice in this example, our base is 3. So you're going to keep your base 3 that whole way, and we're only going down to the end, which is simplifying. So when we simplify at the end, we should have a base of 3 to some positive exponent, okay? So our example here, we are going to solve in our numerator first and simplify that numerator. You're going to have to put that exponent in to both the parts of the base, okay? So keep your keep your base 3, and then you're going to have to use your product law and do 2 times 4. Keep your multiplication sign, keep the base 3 here, and then again product law of 3 times 4, okay, all over 3 to the 5, okay. Then just simplify that, so you have 3 to the 8 times 3 to the 12, all over 3 to the 5, okay. Now still simplifying your numerator using your product law, so you're going to do 8 plus 12. Sorry, I think I called this before your product law. It's your power of power law that you multiply. I apologize. All 3 to the 5, and then you're going to have 3 to the 20, all over 3 to the 5, and now your quotient rule. So you're going to subtract your exponents, so you should get 3 to the 15, and that's what it means by simplifying. So simplifying, so do not evaluate. So that means no putting in your calculator, okay, to solve that. So you're left with as a power, okay? So you're left with 3 to the 15 as a power, okay? Hopefully that example is okay. We'll go on to the next. So here we're going to use our exponent laws to simplify. So here, don't let it confuse you. Your base is a fraction, which is totally fine. So you have 2 over 3 as your fraction. And then it looks like we're going to multiply. It's kind of understood, 2 brackets beside each other, that's multiplication. And then you're going to divide by 2 over 3 to the exponent 6. Okay, so your easiest way to do this is, rather than putting this exponent into both the numerator and denominator let's start by using our product law and adding those exponents. So keep your base of 2 over 3, and you're going to add 4 plus 5. Okay, keep the 2 over 3 to the 6 there. Okay, so you're going to get 2 over 3 to the 9 divided by 2 over 3 to the 6. Okay, use your quotient rule now, subtract those exponents. You're going to get 2 over 3 to the 3. Okay, and this is okay because it asks you to simplify and not evaluate. The only other thing you could do is you could go 2 to the 3 all over 3 to the 3, and then just leave it like that. Okay, so you do not need to, it's simplifying, you do not need to evaluate, so you don't need to put 8 over 27 there. Okay, so you can stop at that step because it just says to simplify. Okay, so on to another example. We're still going to use our exponent laws to simplify. We can't evaluate this one because we have x's as bases. Okay, so make sure that you understand that, like, you can't plug an x in on your calculator to fully evaluate. Okay, so for that, what you're going to do to start is use your power rule. Remember that powers has to go into all of the parts of the base. So the 2 has to go into the 4, and it also has to go into that x squared. Okay, so you're going to get 4 squared, and then you're going to get x to the 2 times 2 using your power rule, and then you can't do anything on your denominator, okay, at least yet. So 4 squared x, and then actually let's simplify 4 squared. 4 squared is 16, and why I'm evaluating that there is because we can actually simplify 16 divided by 8 nicely. Okay, so you're going to get 8x4 all over 8x3. Now just do regular division because you're going to use your quotient rule, right, to be able to get subtract these exponents. So you're going to go 16 divided by 8, which is 2, and then you're going to keep your x, and then you're going to subtract your 2 exponents. So then you're going to get 2x to the exponent 1, but you don't have to, and that's your final step there. Okay, you do not need to write anything to the exponent 1. Remember, it's understood to be 1 if you don't see an exponent. Example 2a here, we're going to express 625 to the exponent 3 as a power of 5. So what you're asking yourself is to figure out what 625 equals as a base of 5, okay, to begin. So the way I like to do this, so you're going to do 5 to the what is equal to 625. So you can either plug that in your calculator, or 5 times 5, so twice is 25 times 5 is 125 times 5, 625. So you know that it would be 5 to the 4 is equal to 625. Okay. However, we have figured out what 625 is, but we still have to deal with this exponent 3. So what you're going to do is you're going to write 625 to the exponent 3, okay? And then you're going to substitute in 5 to the 4 as that exponent, as that power for 625, and then you still have that exponent 3, so you're going to have to multiply it. Then you're going to write 5, and then it is going to be 12. Okay, that is as a power of 5. So if you were to put 625 to the exponent 3 in your calculator, it would spit out the same answer as 5 to the exponent 12. Okay, we'll go through another example on the next slide of this. So you kind of have step 1 here, and then you have step 2 here for actually figuring it out with that exponent 3. Okay. Next slide is kind of the same of example. So you're going to express 1 over 243 as a power of 1 over 3. Okay. So what you're going to do is figure out, to start, what 243 is as a base of 3, and it's because the 243 is in the denominator here, and same with that 3. So let's figure out what it is as a base of 3. Okay, so 243 is equal to 3 to the what? So do that on your calculator. If you know your exponents pretty good, you should know that that's 3 to the exponent 5. Okay, so when you do that, kind of that step 1 is done. Now you need to plug it back into your original expression. So 1 all over 243 is equal to 1 all over 3 to the 5. Or you could write it as 1 all over 3 all to the exponent 5 as well, because then it looks a little bit more like the 1 over 3 of the power, okay? But that is the exact same thing, so that is what you would write there, okay? So there's two examples of kind of your two steps for expressing a power as another power, okay? So here we're going to just do a little bit of math to look for some patterns to figure out what our exponent rule is for 0. Okay, so an exponent of 0. So 2 to the 4 is 16, 8, 4, 2. And if you notice a pattern here, every time, because we're a base 2, we're dividing our answer. So 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and then 2 divided by 2 would be 1. Okay, let's go 3 to the 4. So 81, 27, 9, 3. 3 divided by 3 would be 1. So if you notice, every time you are going to put 2 to the 0 equals 1, that is what gives you your 0 exponent law. So when the base of a power is anything other than 0 and the exponent is a 0, this is your rule, so you can just simply write 1. Okay, there can be some tricky looking questions, and it's pretty funny to see students try to work through them, but they forget that there's an exponent 0 and that the answer is 1. Okay, so let's look at some examples here. So 4 to the 0, 1. X to the 0, 1. Negative 3 to the 0, and because it's in brackets, it will be positive 1. Okay. However, here, the only thing that is to the exponent 0 is that 3. Okay, not the negative. So it's actually going to be negative 1 there. So when you have a negative and there's no brackets, your answer is going to have to keep that negative. Okay, so don't get caught there. This one, the 0, exponent 0, but everything is in brackets, so it's going to be positive 1. Same example here, other than everything isn't in brackets, so the answer is going to be negative 1 because that 0 doesn't go onto the negative out front. Okay, so just keep that in mind when you're doing your homework and any questions on a test. Okay, so again, let's look for patterns here. We look like we have some negative exponents here. So you're going to go 2 to the 1 is 2, 2 to the 0 we just learned is 1, 2 to the negative 1, if you plug that in a calculator, is 1 over 2, 1 over 4, 1 over 8, or again, you're doing 2 divided by 2 is 1, 1 divided by 2 is a half, 1 half divided by 2 is a quarter divided by 2 is an eighth. Okay, then for 3's, you're going to get 3, 1, 1/3, 1/9, 1/27. So this is your negative exponent rule. So all you've done is taken when the exponent of a power is negative, as long as the base is not 0, you're going to flip it and put it as a fraction over 1 with a positive exponent in the denominator. So 2 to the exponent 1 is 2. We have just now have negative 1 though, so it is going to be 1 all over 2 to the 1. Okay, this would be 1 all over 2 squared, which is 1 over 4. This would be 1 all over 2 to the exponent 3. Okay, same here. This would be 1 over 3 to the positive 1, 1 over 3 to the positive 2, 1 over 3 to the positive 3, using that negative exponent law. Okay, so we'll go over some examples there. So it wants you to evaluate these. So again, you see a negative exponent, you're going to put the 1 on the top, keep the base and keep the exponent, but make it positive. And then it does say to evaluate. So evaluate is going to be 1 all over 5 cubed, which is 125. That is evaluating, not putting a decimal. If I ever see a decimal on your quizzes or tests or anything for this unit, I won't mark it. I will just skip over it because you're not allowed to have decimals when we're talking about exponents, okay? So for this one, -7, it doesn't matter that this is negative, okay? So the -2, so you're going to put the 1 keep it in brackets on the bottom, and then put a positive exponent. Because it's in brackets, you're going to do -7 times -7, which becomes positive 49. Remember, you're squaring the negative as well because it's in brackets. Okay, this example here, you're going to have 1 all over -3. Don't put it in brackets. To the positive 3. 1 all over, you're only cubing or doing 3 to the power 3. Leave that negative there. So it's 27, or you can write it as -1 all over 27 with that negative out front. That is fine. Okay. Ooh, what happens here though? When we have 2 all over 3, and then you have a -1, but the base isn't just one number, right? It's a fraction now. All you're going to do is simply flip the fraction and make the exponent positive. Okay, so it's 2 over 3. We're going to go 3 over 2. And then -1 becomes 1. Okay, so then that would just be 3 over 2 because you put the positive 1 into the numerator and denominator, but 3 to the exponent 1 is just 3, and 2 to the exponent 1 is just 2. Okay, but what about this example? So same thing, flip our fraction, so it's going to become 4 over 3. Make this exponent positive, and then put that 4 in, or sorry, that 2 into the base 4 and into the 3. So then you're going to get 16 all over 9, and that doesn't simplify anymore, so that's your final answer there. Okay, so hopefully those make sense. They shouldn't be new to you, but let me know if you have any questions with these ones, okay? Another example, use exponent laws to simplify. So -4 x squared all to the exponent 0, all divided by 2x to the -3. So when you do anything to the exponent 0, it is 1. And then you have 2x to the -3. However, when we are evaluating something like this, we do not want negative exponents. Okay, so you're not done simplifying until you have a positive exponent. So this is like writing, if you were to just look at this denominator, you would write it as 1 all over 2x to the +3, correct? Okay, so if you looked at that, so now you're getting into a triple tiered fraction, which is fine. Another way of looking at that is like 1 divided by 1 all over 2x to the 3. Well, remember, flip and multiply that second fraction. 1 times 2 x to the 3 over 1, or you don't even need to write that 1, it's just 2x to the 3. Okay, so if you see this in the denominator, the negative exponent in the denominator, it actually just goes to the numerator and becomes positive. Okay, a little step or trick there. Okay, last thing we're going to look at for our lesson is refreshing our memories on radical form. Okay, so what do we do when the exponent is a fraction? So we have 4 to the exponent 1 over 2. What we do to solve this is we convert it to radical form, which means finding the nth root of a. Okay, so this is what this looks like. So you have a over 1 all over n, which is the nth root of a. This, you may call it a square root, but it's technically just a root, okay, or a radical, okay? So you're finding the nth root of a. I'll go through examples on the next slide, okay? So I'd maybe copy this out so that you have that written out, okay? So the 4 to the exponent half is like saying it's the second, so denominator is what comes out front. So you're finding the second root of 4, which means finding the square root of 4. So you're finding out what number times itself twice equals 4. And then so you need to solve that. I thought the answer came up. So what you're doing is finding the second root of 4, or what number times itself twice equals 4. So your answer should be 2, because 2 times 2 equals 4. Okay, same thing here again. You take the denominator, that's what goes out front of your radical. Okay, so this means finding the cube root of 27. So what number times itself 3 times equals 27? And well, if you know any exponents, it would be 3. Okay, so your answer there would be 3. So some more examples. Remember, this denominator is the one that comes out front of our radical sign. So you're asking yourself, what number times itself twice equals 81? So your answer should be 9 there. This one is the 4th root of 625. So what number times itself 4 times equals 625? The answer would be 5 there, or there is a way to plug that in on your calculator if you're struggling with that as well. Okay, let me know if you don't remember how to plug that in on your calculator. Okay, but what happens when the numerator of the fraction is not 1? So if you look back, all of our examples, we had a 1 as the numerator in that fraction, okay? So what happens when it's not a 1? So you see like 4 to the exponent 3 over 2. We're going to use the power law, which means that you're going to take a 1 over n, just like you did, and put the m outside of the brackets as another exponent. So then you're going to take the nth root of a all to the exponent m, which I'll show you will make more sense on the next slide through examples. Okay, so for an example here, you're still taking this denominator and putting it out front of the radical. The base still becomes your number under the radical, and then this numerator is what comes out front and acts as another power. Okay, so figure out in the brackets first. So the 3rd root of 27, or what number times itself 3 times equals 27. You should know that that is 3, and then keep your exponent 2 outside, so then you have 3 to the exponent 2, which is 9. Okay, so you're going to follow the same steps for the rest of these. So denominator comes out front of your radical, base goes under the radical, and then the numerator is what comes up here and acts as a regular exponent. So the 5th root of 1024, what number times itself 5 times is equal to 1024 is 4, and then keep that cubed there. So 4 to the exponent 3 is 64. Okay, again, 4th root 2401. Keep the numerator as the exponent outside the brackets. What number times itself 4 times is equal to 2401, which is 7. Keep it to the 5th. Oh, and you'd have to probably plug in on your calculator. Okay, and then this one, keep it the same. So still take the 6th root of 729. Keep the negative with the numerator. Okay, what number times itself 6 times is 729, which is 3 to the negative 5. Well, now you're just working with your negative exponent rule. It's going to be 1 all over 3 to the positive 5, which is 1 all over 243, and you're done evaluating there. Okay, so lots of examples there. I'm just going to go through one more example that looks pretty hard together, just so you're used to some more difficult examples, okay? So here we have used exponent laws to simplify. So 3 to the exponent 2 over 3 times 3 to the exponent negative 1 over 4, all divided by 3 to the exponent 1 over 2 to the power of 5 over 6. Okay, so don't get super worried about this. I'll walk you through it, okay? So let's simplify our numerator to get like by itself and our denominator by itself before we mix the two of them, okay? So on the top you have a multiplication sign, so you know it's a product law. You have the bases the same, which is 3. So if you have the same bases and you're using product law, you're going to add your exponents. Okay. In the denominator, you have power of power rule. So keep your base of 3 and then multiply your exponent. So you're going to get 5. 1 times 5 is 5, and 2 times 6 is 12. Okay, so already the denominator looks a lot nicer. Here, what you need to do to be able to add fractions is get a common denominator. A common denominator between 3 and 4 is 12. So you're going to multiply these ones by 4, these by 3. Okay, so just make sure that you're getting a common denominator. So you're going to have 3 to the 8 over 12, plus a negative would be negative 3 all over 12. Okay, so then you're going to get base 3, and then 8 minus 3 is 5. Keep your denominator as 12. Oh my goodness, what happened here? So 5 over 12 minus 5 over 12 is equal to 0. Well, 3, anything to the power of 0 is 1, so your answer is 1. So we went from all the way this crazy, confusing thing all the way to just a answer of 1. Okay, so don't let anything like that freak you out. Okay, so time for your homework. Lots of examples there, so lots of practice obviously to do. Just let me know if you have any questions with our review of exponent laws and our radical form. Okay, good luck.